Let's talk about polynomial functions. Let's get understanding which functions are polynomial, which functions are not. And we will learn it how to do it, recognize it algebraically, how it recognize it by graphing, and how to build polynomial functions. Though this is our goal in this topic. Maybe I won't fit in one video. I may do several, 2-3 videos, but I'm going to cover all of it. So polynomial functions. Polynomial functions is the function of the form a(n) xn plus a(n minus 1) xn minus 1 plus, as you can see, degree is decreasing, going down, n minus 1. Let me write down also n minus 2. Okay, then we can put dot dot dot, so arrive to a2 x2 plus a1 x to 1, or we don't write, or an x to 0, which will leave only a to 0. So this is what is polynomial. The highest degree of polynomial, as you can see, there refers term a(n) x to n, because after that every degree is going down, and index of a(n) also goes down, n minus 1, n minus 2, all the way to a0. Now, the other thing I want to invite your attention, polynomial is written in descending order. So if you have long polynomial, you want to write down in descending order so it can be easily seen which term is missing, which term is there. So it's shortly saying it's easier to work with. So now let's recognize algebraically how to recognize the polynomial functions. From the beginning, I'll tell you that polynomial function cannot have negative exponent, cannot have fractional exponent. Oops, that's not what I meant. I meant this. That's what cannot be. So polynomials that are acceptable as a function, as a polynomial function, is negative, let's say 3x to 5. I can put here f of x to 5 plus square root 2 and x squared plus 5. So that's the polynomial. Next one, f of x is equal, let's say, negative 3x to 4, x minus 2 times x plus 3. This is also accepted as a polynomial. But what is not polynomial? Let's say if I have f of x is equal negative 3 instead of the square root x, okay, plus square root 2 x squared and plus 5. The square root x shows that this is not a polynomial. Why? Because it's the same thing, 3x to power 1/2. So polynomial cannot have variable under a square root or radical, or cannot have degree in the format of fractions, which is here. Let me see. Cannot have a degree in the format of fraction, cannot have variable under radical, and the rest we can accept. So it doesn't matter that coefficient is under square root. So as long as x is not under square root or radical or fractional exponent, then we would accept it. But since we have exponent in the form of fraction, then we cannot accept it as a polynomial. Another example, let's say g of x. If I write down negative 3 over x squared plus square root 2 x squared plus 5. This is not acceptable from the point of polynomial. We cannot call it polynomial because you have x squared in denominator, and that means we have negative 3 x to negative 2 plus square root 2 x squared plus 5. So because we have here negative exponent, that it's not acceptable from the point of polynomial function. Okay, so as long as we have polynomial function with a degree of whole number, then whole number it says 0 degree, 1, 2, 3. See here in this case, let me write down this way, 5, it's the same thing, 5x to power 0, right? So 0 degree. As long as you have in the degree of whole number, which is 0, 1, 2, 3, 4, and so on, then it's accepted as a polynomial. Everything else is not a polynomial. Okay. Next, every polynomial has degree. It can start from degree of 0. For example, if I write down f of x is equal, let's say, constant c, can be 5, 6, 7, 9, 10, right? And we will get its degree 0. With under condition c is not equal 0, because fx equals 0, that's not polynomial. And why is it degree 0? Because I can write down here x to power 0, right? Which is going to be equal 1, and we get same c. Okay, next example, I can get f of x is equal mx plus b. All right, this one is going to be degree of, that's right, 1, because we have here 1. Okay, if I have f of x is equal ax squared plus bx plus c, the highest degree is 2, right? Although we have degree 1 here also, but highest degree, and highest degree is identifying which one is the degree of polynomial, so we will have 2. Now, it can happen that we can have polynomial with more than one variable, right? Let's say x to 5, y to 7, plus x to 4, y, plus x x and y to 2, for example, and plus 1. How we define which one, what's the degree of polynomial? We need to identify the degree of every single term. Every single term is defined, separated by this plus or minus signs. So degree of first one is 5 plus 7. Degree of second one is 4 plus 1. Degree of third one is 1 plus 2. And degree of third one is 0, because you have what? X to 0, right? Okay. So what do we have? Here we have 12. Here we have 5. Here we have 3. And here is 0. Which one is the highest? 12. So degree is going to be 12. So the highest degree of the term. Okay? So now let's move to recognizing polynomial functions based on graph. Which one we call polynomial functions, how we recognize polynomial function, and how we recognize that it's not polynomial function. All right, let me start building a graph everywhere. Okay. And then next one. Since we are doing, might as well, let's do here. Okay, one more. Oops. Well, okay, this one I drew by hand. So which one we can accept as a polynomial? If I have, let's say, graph like this, and then it can be this, or it can be this way. Also acceptable polynomial. So which one we accept as a polynomial when graph is smooth and it's a smooth graph and we don't have here sharp corner, okay, on curves. Now let me show you the ones, the graphs that cannot be considered polynomial. Here is one. Let's say this one is come this way, and then this comes here. There is a break. If there is break on the graph, it's not a polynomial function. Or if there is a sharp corner, sharp curve. Okay, we have here sharp curve. That's not considered as a polynomial. All right? So that's now we learn how to identify polynomial function based on graph. Okay, now let's start learning elements of polynomial, how to build polynomial. So the first element we are going to start learning, it's an end behavior and leading coefficient. So step number 1, end behavior. God. And leading coefficient. They are kind of tied up, they work together. Okay, leading coefficient. So I will need this graphing axis. I will need this one. Okay. Okay. Let me see if I can copy paste. It would be easier instead of doing 100 times copy. Paste. Okay, it worked. Another one. Paste. Much better. One more. Perfect. We have it. Okay. So, first of all, we are looking at end behavior based on leading coefficient. For that, we need to look at our degree of coefficient, degree of polynomial, and highest degree of polynomial. Remember, we learned here highest degree of polynomial based on highest term, right? So if and I'll do example. So let me take this one. Green one. If highest degree of polynomial n is odd, and we have n is even. All right, so let's look at n is odd and n is even. Two cases when coefficient, the leading coefficient is greater than 0. Which one is leading coefficient? Leading coefficient is this one. The coefficient of the term with highest degree. Because we have xn, highest degree, whatever it is, then the coefficient will be the leading coefficient. Let's say for this case, negative 3x to 5. So you see the highest degree is 5, right? That's mean the polynomial of degree 5, and negative 3 will be our leading coefficient. Now in this case, how we are going to identify negative 3 is going to be leading coefficient, not because this is 4 is greater than that. If you multiply 4, here is also you have 1, and it's all multiplication gonna be, right? And then multiply x to power 1. So you get, when you multiply x to 4 times x to 1 times x to 1, and if you multiply all together, you get x to 6, right? So it's still gonna be the highest degree of polynomial, and the coefficient is gonna be negative 3. We are going to go over. So I will do examples. We will do it. All right. So we are here when a is greater than 0 and when leading coefficient is less than 0. First thing first, when highest degree is odd 1, then what's going to happen? One end gonna fall down, the other end gonna rise up. For the case when n is odd and a nth leading coefficient is greater than 0, then what's going to happen is the right end, it's going to rise, and left end, it's going to fall. Okay? Well, in between, whatever graph it's going to be, that's how it's going to look. Now, because it's rising, it's going up. So trend, if you look at the trend, is moving up, right? Okay. Now, if we have coefficient a is less than 0, but n is still odd, then we will have rising on the left end and falling on the right end. And in the middle is whatever graph is. So if you look at the trend, it's going down, right? Decreasing. So a is less than 0. Okay. Now, for the case when n is even number, when n is even number, then what we have is an leading coefficient a is greater than 0. Then in the case of even degree, highest degree even, then end behavior, both ends are looking in the same side. If it's a coefficient is greater than, then both of them looking up, rising. And the graph is whatever is in there. And if the coefficient is less than, leading coefficient is less than, then both graphs are looking down. And in the middle graph, whatever it's gonna be. So this is our template, first step. Okay, so let me bring example. Let's do a couple of examples here. Let's assume I have x cubed plus 3x squared minus x minus 3. So what is leading coefficient? N is equal 3, right? Leading coefficient is 3. And what is our, excuse me, highest degree? What is the highest degree of variable, which is degree of polynomial, is 3. N is equal 3. Now, what is the leading coefficient? Leading coefficient is 1, yes? Right here, let me make it bold. Which means our leading coefficient is equal 1. So what do we have? Let me see. We have n is equal 3, which is odd, here it is. and we have leading coefficient is 1, which is greater than 0. So we know that the graph is gonna go like this. If you look at the graphing calculator, you will see that the graph goes something like this. And let's check it. So based on the n is equal odd, and based on coefficient is greater than 0, we're supposed to have left end is falling down, right end and is rising, correct? Okay, so that's first one. The second one, let me clean this so not to make mess. Second one, let's do, let's see, negative 4x cubed, let's say x minus 1 squared and x plus 5. Well, right now we are taking from graphing calculator, but once I finish covering every single element of the polynomial function, then we will build ourselves that polynomial function, okay? But as of now, so let's figure it out. How much is the degree of polynomial? So here we have 3 plus, because it's all multiplication. If you open up, get the polynomial, what's going to happen? You are going to add, right? X to power 3 times x to power 2, which is going to be 2, and we will need to add. And plus 1, because we have 1. So let's see, 1 times 2, it's going to be 2 here, and 1 times 1, it's going to be 1. Why I am doing this? Because if you open this parenthesis, and you will start multiplying, this is what's going to be x, right? X to power 3 times x to power 2 times x to power 1. And the degree, it's going to be 6. So the n we have equals 6, correct? And a, it's going to be negative 4. Yes? So n is 6. Where is n is 6? It's even, right? Here we go. We have it even, right? And a is negative 4, which is negative, less than 0. And so our end behavior is going to look both of them down, correct? In the same direction. All right. Whoever has graphing calculator, you can open and see. And the graphing calculator is based on graphing calculator. It's going to be look like this. So both ends looking down, okay, because degree is even, so it's gonna, that's mean either both ends are going up or both ends are going down. And negative 4, which means it decides that it will go down, okay. Let me do one more. Let's say 2x cubed, x minus 1, and x plus 5. So how much is our degree? This is 1, here is 1, here is 1, here is 1. So we get 3 plus 1, because we have 1 times 1, and then plus another 1. So what we get? The 4, 5. Degree is 5. If degree is 5, so the end behavior is going different direction. Either one is up, one is down in the first quadrant, third quadrant, or the left one is up and right one is down. And our leading coefficient, so this is n is equal 5, and leading coefficient is equal 2, which is greater than 0. So it is clear. So if you look at your graphing calculator and build this graph, you will see that this graph is gonna look like following way. Well, it's touching. Okay, and indeed, n is equal 5, So we have down this one and up this one, and it's 2 greater than 0. That's why we have the left one down and right one up. If we would have a is less than 0, we would have left one up right here. A is less than 0. Left one we would have up, and right one we would have down. Okay. So, and let's do one more. Negative, what do we have? Okay, negative 4 x to 4 plus 8x cubed plus 4x squared and plus 2. Okay, highest degree here is 4 because there's no multiplication, it's clearly seen, 4. And coefficient, leading coefficient is negative 4, which is less than 0. Okay, look at the, so we since n is 4, right, it's even, so that's mean end behavior, both of them either go up or it goes down, right? So it all depends on up or down, it depends on leading coefficient, yes? So our leading coefficient is negative, which means it's gonna, both of them are going to go down. All right. If I go like this, it's gonna be something like that. So it's even, right? Degree of polynomial even. So both ends looking on the same side, and coefficient, leading coefficient is negative. That's why they are going down. Okay, and in next video, and I'm recording right away, I will go over zeros of polynomial and multiples of the polynomial. Okay, see you in that video.